If you left Earth right now and aimed your spacecraft toward Andromeda, something strange would happen. You wouldn't just die before you got there. Your descendants would die. Their civilizations would collapse. The sun would swell and burn out. Earth would become dust, and your ship would still be nowhere close. A lot of people imagine that someday we'll visit other galaxies, that we'll build a faster rocket, invent a new engine, slap on a cool name, and just go. But that intuition is wrong. Not because we lack courage, not because we lack intelligence, but because the universe is built on scales that don't care about human ambition. Andromeda, the nearest large galaxy that is still unreachable. Andromeda is the closest large galaxy to the Milky Way, not the closest object, not the closest star system, but the closest galaxy comparable in size to our own. Its distance is about 2.5 million light-years. That number sounds gentle until you remember what a light-year actually means. A light-year is not time, it's a warning. A light-year is distance. It's how far light travels in 1 year, and light is the fastest thing in existence. It moves at about 300,000 kilometers per second. In 1 year, light travels nearly 10 trillion kilometers. Now multiply that by 2.5 million. You get a number so large your brain can't hold it, not because you're bad at math, but because human intuition evolved to judge forests, rivers, and horizons, not intergalactic voids. The fastest thing we've ever made and why it fails. The fastest object humans have ever made is a solar probe. At its peak, it moves faster than anything in history. At that speed, it could circle Earth in minutes. That sounds impressive, but aimed at Andromeda, it would take trillions of years, not millions, not billions, trillions. For perspective, the universe itself is only about 13.8 billion years old, so even our fastest machine would need hundreds of times longer than the age of everything just to arrive. By the time it reached the halfway point, the universe would look nothing like it does today. What if we go much faster? Let's be generous. Imagine a spacecraft that can cruise at 10% the speed of light. That's absurdly fast for human standards. At that speed, the trip takes 25 million years. 25 million years ago on Earth, humans didn't exist. If our ancestors had launched a ship back then, it still wouldn't have arrived yet. What if we cheat and go light speed? Okay, let's break the rules. Let's imagine a ship that somehow travels at the speed of light. No mass limits, no engineering constraints, no reality. Even then, the journey would take 2.5 million years. And here's the problem. Anything with mass cannot reach light speed. As you accelerate, your energy increases, your effective mass increases, and the energy required approaches infinity. Infinity energy does not exist. So light-speed travel isn't delayed, it's forbidden. This is where sci-fi enters the conversation. Warp drives don't technically move faster than light. They bend space itself. Sounds clever. The problem, they require exotic forms of energy we've never observed, in quantities larger than entire stars. Right now, warp drives exist only as equations on paper. Wormholes face the same issue. Even if they exist, they're likely unstable. Anything passing through would be torn apart at the atomic level. So for now, these ideas remain imagination, not transportation. Even if you could go fast, space fights back. Let's say speed wasn't the issue. Space still hates travelers. At extreme velocities, radiation becomes lethal. Temperature swings become violent. Dust particles become bullets. At a fraction of light speed, a grain of sand carries the energy of an explosion. You don't need enemies. The universe itself becomes one. The generation ship problem. So what about a ship that lasts forever? A moving city. Generations born, living, and dying on board. That's not a journey. That's a civilization exile. Millions of years inside a metal shell. No destination visible. No guarantee the ship survives. No guarantee the society remains sane. And even if it did, they would arrive to a galaxy that evolved while they were en route. Here's the twist. Andromeda is coming to us. There's an irony here. We don't need to go to Andromeda. Andromeda is already coming to us. It's drifting toward the Milky Way at hundreds of thousands of kilometers per hour. In about 4 to 5 billion years, the two galaxies will collide and merge. Astronomers even have a name for the result: a combined galaxy, a new cosmic structure. But you won't see it. Neither will I. By then, the sun will be dying. Earth will likely be uninhabitable. The universe runs on its own clock. Looking at Andromeda is looking into time. Here's the part that makes it beautiful. When you look at Andromeda in the night sky, you are not seeing it as it is. You are seeing it as it was 2.5 million years ago. The light left before modern humans existed. If someone in Andromeda looked back at Earth right now, they wouldn't see cities. They wouldn't see satellites. They might see early humans, or just forests and animals. Across galaxies, we don't see space. We see time. You were never meant to go, and that's okay. The universe is not scaled for travel between galaxies. It's scaled for wonder. The fact that you can see another galaxy with your eyes at all is extraordinary. You don't need to visit Andromeda. You are already connected to it by ancient light crossing unimaginable emptiness. That connection is enough. Here's my question for you. If humans could break physics just once, would you rather visit another galaxy or understand this one completely? Drop your answer in the comments. One choice, one reason. And if you want to explore what humanity might become, beyond Earth, beyond tomorrow, beyond 2200, subscribe.